Ajay, am I audible?
Yes.
So in the last class, we have started electric potential. We finished potential due to a point charge. This is the expression for potential due to a point charge. It's Q by 4 pi epsilon naught R. And then we calculate potential due to a system of charges. For a system of charges, potential is algebraic sum of potential due to individual charges. So if you have a system having more than one charge, so what we do is we calculate potential due to each of the individual charge and then we'll add them up algebraically. Potential is a scalar quantity. So we add them up algebraically. This is how we calculate potential due to a point charge. System of charges. So first question on potential due to a system of charges. You have a square. On every vertex of the square, you have a charge E, it's plus E, plus 2E, it's minus E, it's minus 2. The name of this point is A, this point is B, this is C, and this is D. Each side of the square is A. You have to calculate potential at the center of the square. Then you need potential at point, let's say this is some point E. Then you need potential at E. Then you need work done to carry a charge from O2. So calculate potential at first part O, second part E, third part work done in carrying electron from O to E. Write down the question, they will solve it. Okay, so let's start with the solution. So you're supposed to calculate potential at point O. See, you have 4 charges. All 4 charges will generate potential at O. So for total potential at O, we'll first calculate potential due to individual charges and then we will add them up algebraically. So potential at O is sum of potential due to each of individual charges VA, VB, VC, VD. We'll calculate potential due to individual charges and then we will add them up algebraically. This is how we calculate potential at. So to calculate potential, you need this separation. The separation between the side and the center of the square. See, if side of the square is A, then the separation between any corner and center of the square is A by root. So when we calculate potential due to charge at A due at the center, the expression will be K, one instead of 1 over 4 pi epsilon, I'm writing K. Charge is E divided by R. R is A by root. Similarly, at B, you have a charge 2E. Due to 2E, I need potential at the center. So it's K into 2E.
Excuse me, sir.
Yes, Abrat.
Sir, a by root 2 is length of diagonal, right?
Half of length of diagonal.
Half.
Length
Okay.
of diagonal is A root 2. It's half of length of diagonal. It's A by root. Similarly, you have third charge, which is minus E. You need potential at O due to this minus E charge. So it's K into charge minus E divided by A by root 2. Next, you need potential at O due to charge at D. So this is again K. It's minus of 2E divided by A by. So this is how we calculate potential at point. We calculate potential. I'm using this relation KQ by R. So we can take this KE by A by root 2. We can take this term as common. When I take this term as common, this is 1. This is 2. Here, this is minus 1 and this is minus 2. So 1 will cancel with 1, 2 and minus 2. So the net potential point at point O will be 0. That is the first part of the question. When you do the second part, I need potential at E. To calculate potential at E, we will calculate potential due to each of the individual charges. So for E, we will first calculate potential due to charge at A. Then we will calculate potential due to charge at B. Then we'll calculate potential due to C and D. This separation is given as A by 2. I need potential at E. So potential at E will have contributions from each of the 4 charges, E, 2E, minus E and minus 2. So for calculating potential, I will need this separation AE. Minashi, how will you calculate this AE separation? Minashi, how would you calculate this separation AE? Maharaj, how to calculate this separation AE? I need this separation from A to E. See, to calculate potential at E due to this charge, you need this separation, na, AE. How to calculate this potential, Maharaj? This separation, AE. Noha?
So by Pythagoras.
Sir, so we will take a by 2 under root a by 2 square upon plus a square.
Right. See, this is in triangle ABE. You can use Pythagoras theorem. Na? For AE in triangle ABE. ABE. We can use Pythagoras theorem. Pythagoras theorem says that AE is its root over AB square plus BE square. So how much is AB? AB is A, BE is A by 2. So that is root over A square plus A by 2 whole square. So when you solve it, it comes out to be it's A square plus it's A square by 4. So that comes out to be root over 5A square divided by 4. So this is your AE. AE is A by 2 root 5. Similarly, you can calculate DE. DE and AE are equal. So you can write that your DE is, again, it's A by 2 root 5. Next, you need potential at E. That will be the sum of potential due to each of the individual charges. So this is potential due to charge at A, potential due to charge at B, potential due to charge at C, plus potential due to charge at D now. Complete this calculation, get the value of V. First, write the first part of the question, then do this calculation.
What do we have to calculate?
Potential at E.
Okay.
Okay, Alia. Answers. Calculate potential at E and write your answer in chat room. Answers. Minashi, Mazia, Arpit. Potential at E. See, Arpit, you're supposed to calculate potential at point E. So to calculate potential at point E, we will be using the concept of potential due to n charges. We will first calculate potential each of the individual charge at E. Then we will add them up algebraically. So at E, the first charge is plus EE, which will generate potential. So you need this separation AE. So we calculate this separation using Pythagoras theorem. AE is A square A root 5 by 2. So at E, potential due to charge at A will be, it's 1 over 4 pi epsilon naught. Charge is E and separation is A by root 2. Similarly, if you want to calculate potential at E due to charge at B, charge is 2E and separation is A by 2. So this expression will be 1 over 4 pi epsilon naught. It's 2E, separation is A by 2 now. Then you have here C, the separation is A by 2 again. So the potential will be 1 over 4 pi epsilon naught. Charge is minus E and separation is A by 2. Then you have this last charge D. Charge is minus 2E and separation is A root 5 by 2. So this is again 1 over 4 pi epsilon naught. Your charge is minus 2E. Separation is A root 5 divided by 2. No, Minashi, it won't be 0. Huh? So you can take this E by 4 pi epsilon naught A as common. So when you take this term as common, or we can add one more step to it. Huh? Let's add one more step. See, all these root 2's and 2 in denominator will go to numerator. So you can write that VE is 1 over 4 pi epsilon naught. It's 2E divided by A. Similarly, this A will go to numerator, and this is 1 over 4 pi epsilon naught. It's 4E divided by A. This 2 will go to numerator and you will get 1 over 4 pi epsilon naught. It's minus 2E by A. This 2 will again goes to numerator and you will get 1 over 4 pi epsilon naught. It's minus 4E by root 5. Now see, you can take this E by 4 pi epsilon naught A as common. E by 4 pi epsilon naught A as common. When you take this term as common, you will be left with 2 plus 4. Here we have minus 2. And again, sorry. There is one root 5 here also. This is A root 5. This is the separation, A root 5 by 2. So this is 1 root 5 here. So this is 2 by root 5. Plus 4 minus 2. It's minus 4 by root 5 again. So potential at point E is, it's E over 4 pi epsilon naught A. So it's 4 minus 2 will be 2. Minus it's 2 by root over 5. So this is potential at E. Do it. So for point E, calculate potential due to each of the individual charge and then just add them up algebraically. Written?
Yes, sir.
Okay.
Yes.
The last part says, third part of the question.
Just
You need work done in carrying a charge from A to E. Work done in carrying a charge from A to B is charge, potential at E minus potential at A now. So how much is Q? See, Q is electron. So the charge over an electron is, Mazia, how much is charge over an electron? Mazia, what's the value of charge over an electron? Minus E, huh? So it's minus E, potential at E minus potential at A. So it's minus of E. Potential at E is, it's E by 4 pi epsilon naught A. It's 2 minus 2 by root 5.
can't we rationalize this?
Yes, you can rationalize it, but that won't help much. You can leave it here also. So this is minus E square by 4 pi epsilon naught A. It's 2 minus 2 by root 5. If you want, you can rationalize it, doesn't matter. So this is the work done in carrying an electron from O to E now. Note it down. We'll do one more question on the same concept. Anshika, is it clear?
Yes.
Alia?
Again, scroll up a bit, so my second part is I guess.
Okay.
Done.
Okay, solve the next question. The next is comparative easier. So you have two charges, a charge plus E and a charge minus 2E. These two charges are placed at a separation 2A. You're supposed to calculate potential at some point A. Separation between these two charges is A. Separation between these two charges is again A. I need potential at A. Do it.
See, this is a straightforward calculation. Calculate potential at A and write your answer in chat room. Instead of 1/4 pi epsilon naught, you can write K. Huh? So the formula of potential for one charge will be KQ by R. I need answer of each one of you. Mazia, Minashi, Miraj, Noah, answers. Answers, Alia, Arpit. Yes, Yashika is correct. I got just one answer from Yashika. That's it. Noha is correct. Minashi is correct. Mazia, at least try. Uneeb, no, add them up, na. Alia, just add them up. See, this is straightforward. Potential at A is potential due to this charge, which is KE by A. Then potential due to this charge, which is K minus 2E by A. So it will be minus of KE by A, right? So it's KE by A minus 2KE by A minus KE by A. So this is potential at point. This is the value of potential at point. Note it down. See, after potential you do a point charge. The next topic is electric potential due to a dipole. So dipole means a system having equal amount of positive and negative charge. So if you have a dipole, say it's a dipole, one charge is negative, another charge is positive, and this is the center of dipole. From the center of dipole, you are supposed to calculate potential over this point P. The separation is R and this angle is theta. The total length of the dipole is 2a. So this is center. So this is A and this is A again. What's the expression of dipole moment? Alia. Alia, what is the expression of dipole moment? How we calculate dipole moment? P. Mazia, how we calculate dipole moment? What is the formula for dipole moment? Arpit, what is the expression for dipole moment? Okay. Minashi, what's the expression for dipole moment? How to calculate dipole moment?
Q into 2a.
Q into 2a. Dipole moment is charge multiplied by separation between them. This is dipole moment. Q into 2a is dipole moment. So to calculate potential over this point, we will first calculate potential due to positive charge, then we will calculate potential due to negative charge. So this separation is R1. This separation is R2. So potential at P we can write this as Vp is potential due to positive charge plus Q. So I can write this as this is KQ by R1. And then it's potential due to negative charge minus Q. So that's minus KQ over R. You can take KQ as common here. When you take KQ as common, you are left with 1 by R1 minus 1 by R2. So this is potential at P. Potential at P is KQ 1 by R1 minus 1 by R2. That's my first equation. The next step is somehow you have to express this R1 and R2 in terms of A and theta. I need R1 and R2 in terms of A and theta. Just note it down. Then we will do how to convert R1 and R2 in terms of theta. Leave some space below this figure. There is few more constructions here.
Yes. So now we will try to convert this R1 and R2 in terms of R, A, and theta. Now, see, R is greater than R1. So to cut a portion of R which is equal to R1, what we can do is we can just drop a perpendicular from R1 to R. Let's call this point as A, let's call this point as B, and let's say this is some N. So when we draw this perpendicular, this portion is equal to R. So you can say that R1 is almost equal to this Pn. This Pn is equal to R1. And how much is Pn? Pn is Po minus No. Pn is P2O minus N. Po minus No. Po minus N. How much is Po? So P2O separation is R. And for NO, I can use this right angle triangle. So PO is R minus N. For NO, I will use this right angle triangle ONB. In triangle ONB, your cos theta is base upon hypotenuse. So this is base and this is hypotenuse. So this is ON by OB. So you can write your ON as, or you can say this at NO. So it's NO by OB. So your cos theta is, it's NO divided by OB. See how much is OB? OB is A. So I can write this NO as, this NO is A cos theta. A cos theta. Let's call this as equation number 2. So if I substitute this NO here, I get R1 is equal to R minus A cos theta. That is equation number 2. Similarly, we can do one more thing. Like we can convert R2 in terms of R. So to convert R2 in terms of R, what we will do is we will extend this R. This is extended R. And we'll drop a numerical perpendicular from this extended R to this thing. Let's call this as M. So this length PM will be almost equal to R2. So we extend this R and we drop a perpendicular from R2 to extended R. So I can say that this R2 is exactly equal to PM. So I can say that R2 is equal to PM. So PM I can write, this PM is PO plus OM. PO plus OM. How much is PO? So P2O is R plus OM. Now to calculate OM, what we can do is, if this is theta, then this is theta. We can take this cos theta. Cos theta is again its base upon hypotenuse. So that's OM by AO. So it's OM by AO. AO is A. So you can say OM is A cos theta. So when I put these values here, your R2 will become, it's R plus A cos theta. So that's equation 3. So next what we can do is we can substitute 2 and 3 in this one equation. Now we have values of R1 and R2. So when we substitute 2 and 3 in 1, I get potential at P as, it's KQ. It's 1 by R1 R1 is this R minus A cos theta. So it's 1 by R minus A cos theta minus R2, which is 1 by R plus A cos theta. So potential at point P is, it's KQ. We can take this R minus A cos theta and R plus A cos theta as common. So we have R plus A cos theta minus R plus A cos theta. So this R will cancel this R. So potential at P is, it's KQ. It's 2A cos theta. It's R square minus A square cos square. Now, if you can combine Q and 2A, so when we combine Q into 2A, we get P. So potential at P is, it's Kp cos theta over R square minus A square cos square. So this is expression of potential due to a dipole at any general point, Kb cos theta by R square minus A square cos square theta. Then we have some results, like the first thing is, if R is, then we have some approximations like ideal dipole approximation. So for ideal dipole approximation means R is very, very greater than A. If R is very, very greater than A, that means you can write this R square minus A square cos square theta as almost equal to R square. So when I do this substitution here, the potential at point P becomes, it's Kp cos theta over R square. See, this is the exact expression. But this is the expression when you use this approximation, which is small dipole approximation. Case 1. Now, if point lies on axial line, if point lies on axial line. So this is minus Q. This is plus Q. Separation between them is 2A. I'm asking to calculate potential over this point. This is center of dipole and this separation is R. So potential at point P is, for point P, this angle theta should be 0 degree. So if you take point on the axial line, then your theta is 0 degree. So when you substitute this value, then Vp becomes, it's Kp cos 0 divided by R square. So your potential is, it's Kp by R square. So this is potential on the axial line of dipole. For equatorial line, if I take point on the equatorial line, if I take point on equatorial line, then this is minus Q. This is plus Q. This is perpendicular bisector, and this is the equatorial line. Theta is 90 degrees. So on equatorial line, your potential will be P cos 90 over 4 pi epsilon naught R square. Say cos 90 is 0, that means on equatorial line, your potential will be 0. So if you take a dipole, then potential on the equatorial line is 0. You will get potential only on the axial line, which is Kp by R square. Just note it down. You have written up to here, just note it down. Anshika, is this derivation clear? Potential due to a dipole.
Yes, sir.
Just note down this question, then we'll solve it. Yes, note down the question, please. Note down this question and try to draw a rough sketch. Try to draw a rough sketch. This is the x-axis. This is the y-axis. And this is the z-axis. Do it. Written, Mazia, Alia, written this question. Okay, we'll start this numerical together. Mazia, let's start with you. Mazia, on which axis these charges are placed? See, charges minus q and plus q are placed at this point and this point. On which axis this point lies? On x-axis, on y-axis, on z-axis? Mazia, on which axis these points lies? Mazia, you're not in class, huh? Anshika, on which axis these two charges lies?
Sir, x-axis.
X-axis or z-axis? Z, na?
So z-axis.
0, 0 minus and 0, 0 plus a. They lie on z-axis. So this is yours 0, 0 plus a. Here the charge is minus q. And this is 0, 0 minus a. Here the charge is plus q. Minashi, what's the separation between these two charges?
2a.
2a. That's the separation between them. So we can first calculate the dipole moment of the system. The dipole moment of the system is charge multiplied by separation. It's q into 2a. That is the dipole moment of the system, q into 2a. Next, what we can do is, first part, potential at point 0, 0, z. I need potential. 0, 0, z will lie on z-axis. Let's say this is the first point A. And its coordinates are 0, 0, z. Noah, on which line this point lies? It lies on the axial line or on the equatorial line? This 0, 0, z.
Sir,
On the
axial.
axial line, right? This lies on the axis of the dipole. So this is on the axial line. What is the expression of electric field on the axial line of dipole, Udeep? Electric field on the axial line, so not electric field, sorry, potential on the axial line of dipole.
Kp upon r square.
Kp upon r square. So see, your P is Q into 2A. Your R is equal to Z. R is the separation from the center of dipole to the point. So KQ by Z square. This is potential at point A. P part. Miraj, on which axis this point B lies? A00?
So it will lie on the y-axis.
Y-axis. Miraj, A00.
No, sir, no, it's the z-axis.
Z-axis. Sure. Minashi, on which axis this particular point lies?
X-axis.
X-axis. Why Z-axis? X-axis. So your dipole is along Z-axis and your point lies here. This is your point B. So Miraj, this point lies on axial line or on the equatorial line? Dipole along
So
Z-axis. Yes.
it will lie on the
Equatorial line. This lies on the equatorial line. And what is potential on the equatorial line? What is the value of potential on the equatorial line?
0.
0. Potential on the equatorial line is 0. Third one. Then we need potential at point C. C point is A00. This is also third part of the question. 0, A0. This lies on y-axis. So for the dipole, this y-axis lies on the equatorial line. And on the equatorial line, potential is again 0. So potential is 0 at point B, potential is 0 at point C. In the third part, we need work done to carry proton from A to C. Work done in carrying a proton from A to C. Alia, what is the formula to calculate this work done? I need work done to carry proton from A to C. What is the formula to calculate this work done? Yes. Formula is charge, good, potential at C minus potential at A. So proton, the charge is plus E. Potential at C, it's 0. Potential at A, it was K, this is potential at A, na? KQ2A by Z square. So that's minus of E into KQ into 2A over Z square. This is work done in carrying charge from A to C. Just one more thing. Yashika, will this work done depends upon path or it will be independent of path?
Sir, independent of path.
Independent of path. Why?
So work done is independent of path.
Because field electric force is conservative. Always remember that this work done is independent of path. The reason for this work done to be independent of path is the electric forces are conservative. For conservative forces, work done does not depend upon path. Note it down. Anshika, clear? This particular numerical?
Yes, sir.
Okay. So that was potential due to a dipole. After this, we will relate electric field and potential. We'll calculate a relation between field and potential. The topic is electric field as gradient of potential. So no need to do derivation of this particular topic. You will get numericals on it. So we have two types of numericals. In one type of numerical, potential is given and you're supposed to calculate field. In second type of numerical, field is given and it will ask you to calculate potential. These are the two types of numerical. Potential is given and you are supposed to calculate field. In second type of numerical, field is given and you will be asked to calculate potential. So electric field as a gradient of potential. So the expression says that electric field, let's say we take 2 points. We take 2 points. One point A, another point is B. Potential at A is V plus dV. Potential at point B is V. And this is the electric field from A to B. This is electric field from A to B. The separation between point A and B is dr. So we have to relate this electric field, this separation dr and potential. So the potential difference between points A and B is, see, here potential is V plus dV, here potential is V. Minashi, what's the potential difference between A and B?
dr.
dV, right? Potential difference. This V plus dV and V, the difference is dV. And the separation between the 2 points is dr. The expression of field is that field is change in potential with respect to position. This is the expression of field. So if you have change in potential and you have separation, then you can calculate field. This negative sign shows the direction of field. This negative sign shows that direction of field is from high to low potential. One thing. So if I give you, let's say this is point A and this is point B. Potential at A is plus 5 volt. Potential at B is 2 volt. Mazia, what's the direction of field? It's A to B or B to A? Very good. The direction of field is from high to lower potential. This is the direction of field. This is the significance of this negative sign. See how we use this expression. We use the expression like, if I give you this separation, I say that this separation is 2 centimeter. Then between A and B, how much is the potential difference between A and B? Arpit, what is potential difference between A and B? Arpit. Noha, what's the value of potential difference between A and B? A and B potential difference. Alia? Zero. Okay. Unib, at A potential is 5 volt, B potential is 2 volt. What's the difference in potential?
Sir, 3.
3 volt, yeah, it's 3 volt. 3 volt. Separation is 2 meter. If I ask you to calculate field, then field is minus of dV over dr. How much is dV? It's 3. How much is dr? It's 2. So it's 3 by 2 volt per meter. This is the field. This is how we calculate field if potential is given. This is the meaning of this expression. We can use this expression in various forms. See, if I write minus of dv over dx, you're dividing or differentiating with respect to x, then you will get x component of field. If you differentiate it with respect to y, then you will get y component of field. If you differentiate it with respect to z, then you will get z component of field. So we need x component of field, y component of field, and z component of field. This is how we calculate field if potential is given. So, for example, so if your potential is 3x square, means your potential is changing along x-axis, and asks you to calculate x component of field, then x component of field will be simply minus of dv over dx. Just differentiate this potential with respect to position. So it's minus of d over dx of 3x square. You can take this 3 outside. It's just x square. The derivative of x square is 2x. So we get minus of 6x Newton per. This is field if potential is given. Just differentiate your potential with respect to position and you get. Similarly, if I write that potential is some y cube, then you will get y component of field, which is minus of dv over dy. So it's minus of d over dy of y cube. And derivative of y cube is 3y square. So this is minus of 3y square. So if your potential is given, then just differentiate your potential and you can get field. But remember, if your potential is changing along x-axis, then you will get x component of field. If your potential is changing along y-axis, then you will get y component of field. Similarly, z component of field. But if potential is function of x, y, and z all, like potential is given in this form, it depends upon x, y, and as well as z. So that means your potential is a function of 3 variables, a potential of a function of x variable, y variable, and z variable. In this particular case, your field will have x component, y component, as well as z component. See, potential is changing along x-axis, so we'll have x component of field. It's changing along y-axis, you will have y component. Changing along z-axis, so you will have z component of field. So x component of field is minus of del v over del x. Y component of field is minus of del v over del y. Z component of field is minus of del v over del z. Now, if you want total field, then total field will be Ex I cap, Ey j cap, Ez k. This is how we calculate total field. And these are partial derivatives, not normal derivatives, they are partial derivatives. There's one more thing. If potential is constant, if potential is constant in a region, if potential is constant, then its derivative would be 0. And you can say that field is 0. So field will exist only if potential change. If potential is constant in a region, that means your field is constant. Another example, if I give you field, this is the direction of field. I'm giving you 2 points, point A and point B. Can you compare potential at A and B, Anshika? Which point is at higher potential and which one is at lower potential?
सर दोनों की सेम होगी
No.
because
No. Field exists. If potential is same, then field will be 0. See, read this statement. Just read this statement, Anshika. Huh? Now tell me, A and B, which one is at higher potential?
Sir, B.
No. See, potential field is from higher to lower. What is the direction of field, Anshika? It's from A to B or B to A? Just look
Sir,
at this.
A to B. So
A
A
to B.
must be the higher one.
A must be the higher one. So A is at higher potential. Okay. So A is at higher potential as compared to point B. Just note it down. So that's the relation between field and potential. So if you have potential, differentiate potential with respect to field position, and you will get field. Can I scroll it now? Okay, so this completes potential. In the next class, we'll start with potential energy. So potential is over. From next class, we'll start with potential energy. Okay, so let's stop here.